Hello, can you solve for x and y in this Olympiad mathematics question? What math method can you use to solve this question? I want you to pause this video a little, try solving it, and if you can't, join me as we solve it. We're given x to the power of y minus y to the power of x equal to 17. Now let's get started. To solve this, I'm going to assume one simple assumption that the value of x to the power of y is equal to x to the power of y multiplied by 2 divided by 2. I haven't changed anything. And from this expression, comparing this with the laws of indices, I can have this to become x to the power of y divided by 2 and all multiplied by the square of 2. I didn't change anything. Now, the next one, I'm going to apply that to y to the power of 2. This will give me y to the power of x multiplied by 2 divided by 2, and this will be equal to y to the power of x divided by 2 and all to the power of 2. Great. Now that simply tells me that I can replace these two values I've derived for this expression by this and this. So if I do that, that expression is now going to give me the value of my x to the power of y divided by 2 all squared minus y to the power of x divided by 2 all squared to be equal to 17. Let me assume that x to the power of y divided by 2 is simply equal to m, and my y to the power of x divided by 2 is simply n. So that means I can replace them with that expression. If I replace them with that expression, I'm going to have my m squared minus n squared to be equal to 17. Great. Now, having gotten this, I can simply simplify. Now, I want you to recall one simple laws of algebra, and that is a diff of two squares. From that diff of two squares, if I have the value of a square subtracting b square, that expression will simply give me a plus b and a minus b. Now, gotten that, we can expand that expression to give me n plus n and what? M minus n, and this will be equal to 17. Now, with this expression, I can expand this expression knowing that my 17 can simply be equal to 17 multiplied by 1, or it can be 1 multiplied by 17. Now, from this expression, you can see that m plus n is simply greater than m minus n. So I'm going to take one of this expression, and with that expression, I can solve for m and n. Now, let me take m plus n to be equal to 17, this to be equal to this, while this be equal to this. Now, if I take that, I'm going to have my m minus n to also be equal to 1. So I'll assume this to be equation 1 and assume this to be equation 2. Solving these two equations using the laws of solving simultaneous equation, I will have to add the two equations. Now, if I add the two equations, I'm going to have this cut out this will become 0, and then m plus m will give me 2m, and this will be equal to 17 plus 1 will give me 18. So from here, I can say 2m can divide 2, and this will be equal to 18 divided by 2. So if such divisions happens, then my m will be equal to 9. And that is the first solution to m. Now on the other side, if I decide to find the value of n, let me take the first expression that my m plus n is equal to 17. So having these two expressions, inserting the value of 9 for m, I can have 9 plus n will be equal to 17. And hence, my n will be equal to 17 minus 9, where n will be equal to 17 minus 9 is simply going to be 8. And this is the value of n for that expression given to us above. Now, if these two expressions are the solutions to that expression, remember we assumed initially that the value of x to the power of y divided by 2 is equal to m, and y to the power of x divided by 2 is equal to n. From our initial expression, we are asked to find the value of x and y. So let's simply go back to look for the value of x and y. Having given us that the value of x to the power of y divided by 2 is equal to m, and y to the power of x divided by 2 is equal to n. Inserting the value for m there, we'll have x to the power of y divided by 2 to be equal to 9. If I take the square of both sides, this expression will give me x to the power of y divided by 2 all squared, and this will be equal to 3 to the power of 2, which I know is 9, or what? All squared. So what do we have? This will cancel out this, and then we'll have x to the power of y to be equal to, simplifying this will multiply this, and then we'll have 3 to the power of 4. So x to the power of y is equal to 3 to the power of 4. Now let's come over to this side. This other side will have y to the power of x divided by 2 to be equal to 8. So what do we have? If we square both sides, we're going to have y to the power of x divided by 2 all squared, and this will be equal to 4 multiplied by 2, which is 8 all squared. Now if you simplify this will simply cut out this, and then we'll have y to the power of x to be equal to 4 square multiplied by 2 square. And hence, if we simplify that, we are simply going to have the y to the power of x to be equal to 4 square multiplied by 4 to the power of 1. And hence, y to the power of x will be equal to 4 to the power of 3. Now, do you notice something? From these two expressions, you can see that we have simply gotten the values of our x and y. From these two expressions, we can say that the value of our x is equal to 3 and the value of our y is equal to 4. Because these have same base with 4, y is 4 here, y has a base of 4, x has a base of 3, and x have a power of 3 here. So this is the solution to that math expression given to us. Now let's verify or check to confirm our solution is actually right. To verify, let's insert the value of x and y into the original expression. The original expression given to us is x to the power of y minus y to the power of x equal to 17. Now, if we insert this, can it give us 17? This is going to give us x, which is 3 to the power of 4, minus y, which is 4 to the power of 3. Will the solution give us 17? Let's see. If we do this, 3 to the power of 4 is simply going to give us 81, right? 81 minus 4 to the power of 3 will give us 64. With the subtraction of this give us 17. Sure, this is 17. 81 minus 64 is 17, and then this is equal to 17. So that shows us that the value of our x equal to 3 and y equal to 4 are simply the solution that satisfies the mathematics equation given to us up here. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.